In this video, we're going to learn how to calculate pH, POH, H+, and OH-. As a refresher, in our Introducing Acids and Bases video, we talked about some equations that we need to know. So we're just going to review those quickly. We know that pH plus POH equals 14, and that's based on the pH scale. We know that in order to calculate pH, we have to take the negative log of H plus or H3O plus. You can sometimes see it written both ways. We know to find the POH, we're going to take the negative log of OH minus, or the negative log of the concentration. That's what the brackets mean, the concentration of hydroxide. In order to get H plus or H3O plus, we can take 1 times 10 to the negative pH, and in order to get the concentration of OH minus, we can do 1 times 10 to the negative POH. So we're going to use those equations to help us solve some practice problems. Okay, so here are a couple of practice problems that I want to go over with you. And so we're going to read the first one together. The first one says, calculate the pH and the POH of a solution of HCl with a concentration of 1.0 times 10 to the negative 2 molar. Now remember that we do have to use concentration. That concentration must be in molarity, or capital M. Okay, so the first thing I have to do is I have to decide, am I going to find pH first or am I going to find POH? Because it depends on my what I'm given. I've been given HCl. Well, I know that HCl, when it dissociates, is going to make HCl is going to ionize into H plus and Cl minus. Since it's going to be producing an H plus, I know according to the Arrhenius theory that that is going to be an acid. Since it is an acid, I'm going to find pH first. Acids, we're always going to use pH first. Okay, so I'm going to look for pH. Well, I have to see what the ratio is. For every 1 HCl, I'm going to be given 1 H+. So that means that my concentration of HCl is equal to my concentration of H+. If I was given 5 HCl's, I would get 5 H+'s. 10 HCl's, I'd be getting 10 H+'s. So the concentration that they're giving me is 1.0 times 10 to the negative 2. So if I have 1.0 times 10 to the negative 2 molar solution of HCl, it's going to produce 1.0 times 10 to the negative 2 concentration of H+. So in order to find pH, I know according to my reaction sheet, pH is the negative log of the concentration of H. So I'm going to take pH equals negative log of the concentration of H. So I'm going to plug in negative log, and I'm going to plug in my concentration of H. So that's going to be 1.0 times 10 to the negative 2. And so I just have to put that into the calculator now. Okay, so I'm going to type 1.0 EE, remember, means times 10 to the negative 2. Okay, so it takes that value, and I'm going to need to take the log of that, and then I have to take the opposite of that, or times it by negative 1. So if it was negative 2, the times negative 1, that will give me 2. So my pH is 2. pH equals 2, which makes sense because it's an acid, so an acid should have a pH of less than 7. Okay, but it also wants the POH. So how am I going to get the POH from the pH? Well, I know that the pH plus the POH has to equal 14. So what plus 2 will give me 14? 12. So POH equals 12, and that's because 2 plus 12 equals 14, which is one of the deciding factors on our pH scale. Okay, so remember it was an acid, so I had to find pH. I dissociated it and I found what the ratio was, plugged the concentration in for H, got my pH, and then I took 14 minus my pH, and it gave me my POH of 12. Okay, so let's look at the second problem. The second problem says, calculate the pH and the POH of a solution of NaOH with a concentration of 1.0 times 10 to the negative 4. Okay, so again, I'm going to look at my compound, NaOH. Well, I know according to the Arrhenius theory, NaOH, when it separates, NaOH is going to dissociate or ionize into Na and OH. It's Na plus and OH minus. Since it's producing OH, I know it's a base. Since it is a base, I'm going to have to find the POH first. Okay, so let's look at my ratio. For every 1 NaOH, I'll be making 1 Na, so I have a 1-to-1 ratio, which means that I can just use the concentration of NaOH. So I'm going to be using 1.0 times 10 to the negative 4. Okay, so POH equals negative log the concentration of OH minus. So I'm going to use the negative log of 1.0 times 10 to the negative 4. Okay, so I have 1.0 times 10 to the negative 4. I'm going to take the log of that, and then I have to reverse the sign. So since it's a negative, it's going to become positive 4. So the POH equals 4, which would mean that the pH would equal 10. And remember, that's because the 4 and the 10 together must add up to 14. So my answer would be POH of 4 and a pH of 10. Let's see if that makes sense. I know that this is a base, so the pH should be greater than 7, and it is because it's 10. Okay, so now remember, there's a difference between the two problems. Since it was HCl and it was an acid, I found the pH first. Since NaOH produced OH and was a base, I had to find the POH first. So let's look at the next problem. Let's decide what we have to do. Calculate the pH and the POH of a solution of CaOH2, or calcium hydroxide, with a concentration of 1.0 times 10 to the negative 5. Okay, so we've got to ask ourselves, what are we going to do? It's CaOH2. CaOH2. When that ionizes, I get Ca and 2 OHs. Since it produces OH, I'm going to be finding my POH first. So I have to find my ratio. For every 1 calcium hydroxide I put in, I'm going to be getting 2 OHs. So that's a 1:2 ratio. So if I put 5 calcium hydroxide in, I would be getting 10 OHs. If I put 3 calcium hydroxides in, I would be getting 6 OHs. So if I'm putting 1.0 times 10 to the negative 5 in, I have to multiply that by 2. So I have to say 1.0 times 10 to the negative 5 and multiply that by 2. When I type that into my calculator, I get 2.0 times 10 to the negative 5. So that is my concentration of OH. 2.0 times 10 to the negative 5. And remember, that was because it was a 1:2 ratio. So I'm going to find my POH. POH equals the negative log of the concentration of OH. So I have the negative log of 2.0 times 10 to the negative 5. So I'm going to type that into the calculator. 2.0 times 10 to the negative 5. The log, the negative of that, I get 4.698. So I'm going to have 4.7. 4.7 is my POH. Okay, so then what's my pH going to be? Well, 14 minus 4.7 is 9.3. So my pH is going to be 9.3. I have to ask myself, does that make sense? CaOH2 is a base, so it should have a high pH, and it does. Now remember, the difference between the second and third problem is that NaOH had a 1:1 ratio, so I was able to just plug the concentration in. But CaOH2 had a 1:2 ratio, so I had to multiply the concentration by 2 before I... Alright, so for this last problem, it says calculate the concentration of H3O plus if a solution has a pH of 7.3. What is the concentration of OH minus? Okay, so we know from our equation sheet that H3O plus equals 10 to the negative pH. So I need to take 10 to the negative 7.3. Okay, so in my calculator, I'm going to type in 7.3 negative, and I'm going to hit, take that to the 10 to the 7.3. So in this calculator, I'm going to hit second and then 10 to the x, and so I get 0.0000005. Okay, so if I count that back, 1, 2, 3, 4, 5, 6, 7, 8, I get 5.0 times 10 to the negative 8. So I get that my concentration of H plus equals 5.0 times 10 to the negative 8. If I'm not sure about that, I can always go back and say, okay, so if my H plus equals this, I need to make my pH equal 7.3, so I can plug it back in. So I can say negative log of this value. So I'm just going to do that. I'm going to take the log of that value and then the negative, and it would be 7.3. So I know that I've entered it correctly. Okay, so that's going to be the concentration of H plus. But it also asked me for the concentration of OH minus. So how am I going to do that? Well, I know that the concentration of OH minus is going to equal 10 to the negative POH. Okay, so what's my POH going to be? Well, if my pH was 7.3, 14 minus 7.3, 14 minus 7.3 gives me not that, 14 minus 7.3, gives me 6.7. Okay, so I'm going to take pH the negative 6.7 because that's POH. Because remember, 7.3 plus 6.7 add up to 14. Okay, so I'm just going to plug that into my calculator again. So I have a 6.7 negative, and I'm going to take 10 to that value, and I get 1, 2, 3, 4, 5, 6, 7. 2.0 times 10 to the negative 7 equals my concentration of OH minus. To double check my answer, I'm just going to hit the log of that, and I get negative 6.7, which is what I want. So this is going to be my concentration of OH minus, and this is my concentration of H plus. Remember, just taking it 10 to the negative pH. Okay, so in this video, for calculating pH, POH, H plus, and OH minus, we use the equations that we were given. We know that pH plus POH equals 14. We know that the pH and the POH is just the negative log of the concentration. And we know in order to get the concentration, we have to take 10 to the negative pH or 10 to the negative POH. The other thing that we learned in this is we had to pay attention to whether we were given an acid or a base. If we were given an acid, we find the pH first. If we're given a base, we find the POH first. We also learned that if it dissociates and it is not a 1-to-1 ratio, we must multiply the concentration by the ratio. So we had to take the concentration and multiply it by 2 before we could plug it in, since it had a 1-to-2 ratio. Okay, good luck. I hope that you understand calculating pH, POH, H plus, and OH minus much better now.